we will discuss three major components of a BMW 6-cylinder engine: the cylinder head, a connecting rod, and the camshaft.
BMW aluminum cylinder heads are sandcasted using a complex mold, followed by various machining processes to make the casting usable on the engine block. Signs that a part is cast is the irregular surface finish that you can see in the water jackets. Also, the complex geometry inside there is impossible to machine from billet. The valve seats and valve guides are pressed in for a heated slip fit. The raised BMW symbol and part number are also a sure sign that this head was casted. Once again, you can see the irregular shape of the intake ports that would be difficult to machine. The face of the intake and exhaust ports, the top and the bottom of the head where the mating surfaces are, get machined surface flat for a good seal. The rocker shafts and camshaft journals are through bored to have perfectly concentric circles and a good surface finish for superior oiling. The head is also drilled and tapped for studs to attach the intake and exhaust manifolds to their ports.
Here is a connecting rod made out of steel for cost, durability, and longevity. It seems these rods have been forged and then machined. This is indicated by the separation of the cap and the main body. Another clue is the structure of the grains, which are seen flowing around the outer edge of the cap. In contrast, cut steel would have grains uniform with the cut. Once the connecting rod has been forged into its raw form, it is then machined using some form of CNC milling. The side channels are evidence that machining is apparent, whereas a process like casting leaves a rough surface. It seems the machining process involves boring and honing to assemble the cap to the main body. The machining process may also involve drilling and tapping holes for the bolts, as well as pressing for the bushings. Machining gives the rods correct sizing and great finish.
Here is our camshaft. We believe this part was made through sand casting and then turning. In our opinion, the camshaft was sand casted because of the very obvious parting line going all the way down the part on both sides. This is where the molds were pressed together. Another reason why we believe this camshaft was sand casted is because of the poor finish on the part of the shaft that was not turned. After it was sand casted, the camshaft was turned on the surface layers to get the correct profile and smoother finish. Last, the holes on the front and the back of the shaft were drilled and tapped. An alternative way of manufacturing this camshaft could have been by grinding or turning the entire shaft. We know this is not the case though because of the very evident parting lines and from the poor finish that looks like sand grains.